Welcome to chapter 3.3, called partial differentiation, and being the last part of these functions of higher dimensions. So to explain what partial differentiation is about, I'm going to go back to this slide, which now I'm using quite often. Remember last semesters you were seeing functions f of x. So x is a scalar input and f is a scalar output. And you learned how to do differentiation of f of x. Now in the last chapters we saw when you have a vector that depends on a variable x or t or whatever, then you can also do differentiation of vectors and even integration of vectors, and it was very easy. You had to do the differentiation or the integration of each component of the vector. So this was relatively straightforward. But now we start to get into the interesting part. So what if we have multiple inputs? Okay? And let's start with a simpler case. We have multiple inputs, but only one output. This is a function f, which depends on many variables. It's f of x1, x2, x3, up to xn in general. Okay? So then I'm going to teach you how to do differentiation in this case. And this is called partial differentiation. And don't be scared with the name, because it's actually really straightforward. At the end of the chapter, we will also look at the case when you have multiple outputs. So you have a vector which depends on many variables. And this is, of course, the most general case that exists. Okay? So we are going to look at these two situations, doing the derivatives when there are many variables in the input. So let's get to it.